Now, SQL is really nice because it's you can do computations in it, which is something you can't do with proc print. So for example, let's say I wanted to pick color, and then I'm going to add up X and Y. Now in base SAS, think about what you would have to do. You'd first have to have a data step and compute a new variable total equals X plus Y after setting that data set. Then you'd have to come back and do the proc print. So that's 2 steps, 2 passes, whereas SQL lets you compute that sum on the fly. So this says make a new variable that is the sum of X plus Y, and we're going to call that variable or label it as total. So if we go look at the output, you're going to see a variable in the output called total, and it's just the sum of X and Y. As if you go back to the previous page, actually go back 2 pages, 3 pages. First row, the sum is 3. Second row should be 7, then 11. So 3, 7, and 11, it looks like it worked. Then, if we took something like amount over X, we could call that a new variable average. Now I'm doing some division by X, so I probably want to protect myself from division by 0 errors. So let's only take records where X is non-zero or positive. So that's the most basic version of this as command. In addition to that, we can do all sorts of functions. So, for example, if I wanted to compute the mean of the x's, so I think the x's were 1, 3, and 5, so the mean would be 3. You'll see that down here. So let's pick the mean of x as average of x. Pick the maximum value of y, we'll call it max y. Add up all the amounts, call it totals, and then let's count the colors. And we're going to call the variable n. And so here's the result. So in essence, what you're getting from SQL is also proc means. This is exactly what you get from proc means, except here you have to do a little bit more typing. You have to tell exactly what you want. Here's a pretty comprehensive set of options that you can pull out from SQL. So in some instances, the SQL command is different than the SAS command. So for example, the SQL command for mean is average, but SAS SQL will also support mean. Likewise, SQL uses the keyword count to count the records, whereas proc means would use n. So again, you can use either, but if you're on some other implementation, use AVG and count, because n and mean may not work. Now these functions are quite useful. So they enable us to do everything that we do with proc summary. So how would we make an RFM1 data set from, say, DMEF1? Well, here's the SQL for it, and it resembles what you get with proc summary, the way you would think of doing proc summary. I've added something new here. Create table cur.rfm as. So this is kind of like saying output to a proc mean statement. It says I want you to send the output of this not to the screen, but to this new data set called cur.rfm. So it's completely analogous to you having an output statement without equals with proc means. Now, what do I want to put in this table? So notice I haven't put the semicolon yet. So we're going to make this new table as select customer ID, then we're going to pick the min of date and call it recency. So just like we would with proc summary. Then we're going to count the number of dates, call that frequency. We're going to sum up the dollars, call that totals. I might as well find the average donation amount, which would be the mean of dollars, and call that average dollars. Now we'll do it from this data set. The key here is I'm going to add this group by statement. So group by tells SAS, it's like the by statement or the class statement with proc means. So you're going to have one record per customer ID. It's completely analogous to those by or class statements. One more thing, if we go back to the basic syntax, these have to be in order. So it's create table, then select, from, where, group by, order by. We've not talked about having yet. So let's go talk about having at this point. So if you want to restrict variables, based on their raw values in the data set, we use a where statement. So earlier we said something like where x is greater than 1. Right? And that means if the raw value is greater than 1, keep this record. If you want to restrict records based on group by variables, you have to use the having statement. So let's say I wanted to make an RFM data set, and I only want to include records where recency is less than or equal to 12. So people who are, we're only going to keep the, keep customers where their recent value, these are 1 year actives. They've made a donation within the past year. So how would I do that? So we're going to create this table. We're going to pick all the variables just as we had before. Maybe I want to slap some formats on, fine. We're going to group by ID, so there's nothing really new here. What's new is this statement. So having recency less than or equal to 12 tells SQL only pick those values such that this variable that I've created at the customer level is less than or equal to 12. And you could see the raw data down here. All right, so that's it. We're going to talk a lot more about merges in the next lecture, but if I wanted to merge this RFM data set that I created with the customer table, here's how I'm going to do it. So the most basic merge is, let's pick all the variables from these two data sets. Note they're separated by commas, not by a space. And then we have to do a join on some variable. So with the merge statement, we have that by in there that tells what variable to use. Here we're going to do it in a where statement. So we say where onecust.id. So what that means is take the ID variable that's located in onecust and match that up with the ID variable in this RFM data set. So you separate them by periods. And here's the result. So notice we've added the gender and the state, as well as the future spend amount. Now these functions will also work across columns, and they work in essentially the same way as they work with proc with a data step, with the functions in a data step. So I've made a little data set where we've scattered some missing values in there. So record 1 has no missing values. 2, well, the second variable is missing. Record 3, the first variable is missing. Record 4, both are missing. So every possible combination. Now let's go look at my select statement. So let's pick the original data, so ID x1, x2. Then let's use n of x1 and x2. So this is just going to count the number of variables with non-missing values. We'll call that n x1, x2. So if you look down at the output, that first record has 2 non-missing values. The next two have 2 non-missing, right? The next two have 1 non-missing, and the last one has no non-missing values, so both are missing. We can do a sum, and so look what happens with there. So sum adds up whatever it can. So sum plus missing is, or a number plus missing is the number. So here you get 7. 4 plus missing is 4. Missing plus 3 is 3. And then missing with missing is missing. Contrast that with the plus statement. So if we did x1 plus x2, notice what happens. So 4 plus missing is missing. 3 plus missing is missing, and so forth. Note mean averages whatever it has, and then min finds the min of whatever it has. So again, if you understand how to do this in a data step, it's pretty much the same in a